In this problem, we're told that a particle projected from ground level at an angle of 30 degrees to the horizontal with this speed of 14.7. Well, what that means is here's ground, and it's sent up at a speed of 14.7. Well, that means that there is an x component here and a y component here. And so my velocity is comprised of the x and the y. So it's going to be x and the y, which this value here is going to be 14.7 cosine of 30 degrees, because this angle we're told is 30, and this is the adjacent. And so if you do the calculations, I know that x of x over 14.7 is equal to the cosine of 30. So this x value is 14.7 cosine of 30. And similarly, the y value here will be the sine of 30. So the 14.7 sine of 30, which is equal to 12.7 and 7.35 is the initial velocity of my particular particle, the initial velocity. This is A part. In B part, we're asked to find an expression for the velocity of the particle at time t. Well, we know the initial velocity is this vector here, and it's a projectile, so I know acceleration is going to be always gravity going downwards. Is going to be 0 in the x value and minus gravity in the y, and gravity is equal to 9.8 meters per second. And so if I want to find the velocity, then, well, I integrate this and I get a constant and minus g at t plus another constant. I know when t equals 0, I get these values here. And so if I do e at 0, I'm going to get 12.7 and 7.35, which will equal to C1. And well, if t is 0, this is going to be 0, and this is going to be C2. And so then my velocity, put it over here, my velocity function will be 12.7 and minus gt plus 7.35 is going to be my velocity function, and this is meters per second. Now we want to find the time at which the particle attains its greatest height. Well, if we want to find the maximum height here, but we recognize it's a projectile going on here, so we know we have got shot up in here, and this here, my velocity, my horizontal velocity is going to be fixed, as you can see at 12.7. It's my vertical velocity. It's going upwards, and then it starts going downwards. At this very moment, the vertical velocity is equal to 0. So that means for C part, I'm going to take my y component plus 7.35 and set it equal to 0. And t will then be equal to 7.35 over 9.8, which is the gravity. And that I know is 0.75 meters per second. Moving on to D part, it says find an expression for the displacement of the particle. Well, the displacement means we're going to take our velocity here and we are going to integrate it. So d is the velocity is equal to 12.7 and negative gt plus 7.35. So my displacement is going to be 12.7 t, taking the integral, and negative g over 2 t squared plus 7.35 t t. Now each of these are plus constants, but I know from the context of the problem the initial position is 0, 0. So when I put time as 0, these values will also be 0, and so I don't actually need to have these here at all. So here is indeed my displacement vector. Okay, continue along here. Now we want to find the greatest height reached by the particle. So if we want to find the greatest height, well, we know from C part at the time at which the greatest height happens. So we want to find the greatest height, we use the t from the time from C and we use it in E part. And so from C, we know the time was 0.75, and we use that in our maximum height. And we're looking for a height, so I'm just looking at my thing. I'm looking for a maximum height, so I only actually need this component here, and so it's going to be negative 9.8 over 2 times the 0.75 squared plus 7.35 times 0.75. Because this is the y value of displacement. This will tell me how high the particle goes. And when I do that calculation, I end up with 2.75 meters. All right. This was E part. And so going to F part now. If we look at F, it says, find the horizontal distance traveled by the particle while in flight. Well, that means we need to find when this projectile goes back to 0. So that means when is the r of t equal to 0 for the y value? And so we go back to our displacement vector, we take a look at our y value, and we say minus 9.8 over 2 t squared plus 7.35 t is equal to 0. And if we use polysimultaneous to solve that, I end up with t being 0.15 seconds. And finally, so the horizontal distance happens at this value. So I know this is the vertical distance. So now I have to go to the horizontal distance, the x value. If I plug that into my x value, it'll be 12.7 times the 1.5, which gives me 19.08 meters is the horizontal distance. And finally, the last question, G part says, find the minimum speed attained by the particle during its flight. The minimum speed. Well, speed is equal to the magnitude of the velocity. So here is my velocity. And if I want to find the speed, I'm going to take that velocity and I need to find the magnitude of it. So the magnitude of it's going to be the square root of 12.7 squared plus minus 9.8t plus 7.35 squared. And I want this to be a minimum. Well, if I think about this particular equation here, I recognize that this is fixed. That's never going to be anything other than what it is. It's this part here with the t. This part here changes. If I can get this value to be 0, then the entire calculation here will be as small as possible. And so I then just make the equation negative 9.8t plus 7.35 is equal to 0. And I solve for t, and I get t and it up. Right, and so we know t is going to be whatever it is, but the key is that this is 0, so that goes away. And so then the minimum velocity is the square root of 12.7 squared, which is just 12.7 meters per second is going to be the minimum velocity, or rather speed, I should say.